Hello students, this question is taken from test series 4 IN from the subject measurements from the topic basic of measurement and error analysis, and it is of 2 marks question. In the given question, having the two resistance, that is R1 and R2, are given as 1000 ohms and 500 ohms, which is nothing but R1 is 1000 ohms and R2 is 500 ohms with tolerance if 2.5% and 2% respectively. It is nothing but having the R1 resistance 1000 ohms is having tolerance 2.5% and R2 resistance 500 ohms is having the tolerance 2% respectively. That resistance are connected in parallel circuit combination. The equivalent resistance with uncertainty is dash. We have to find the value of equivalent resistance for the parallel combination with uncertainty is dash. So for the parallel circuit combination, the value of resistance in parallel, the R equivalent is nothing but R1 R2 by R1 plus R2. We know the value for R equivalent for parallel circuit combination. So given tolerance of for R1 resistance is 2.5%, that is nothing but tolerance 1 is equal to 0.025. 2.5% is nothing but 0.025 into given R1 resistance 1000 ohms, 1000 is equal to 25 ohms. The tolerance 1 is 25 ohms. Same for tolerance 2, 0.02 into 500 will get the value of 10 ohms. So apply for parallel combination circuit, solve the value of R equivalent, that is R equivalent is equal to R1 R2 by R1 plus R2 for parallel combination. We know the value of R1 is given 1000 into R2 is 500 divided by 1000 plus 500 will get the value of R equivalent as 333.3 ohms. So we know the value of R equivalent, then we can find the value of I1 I2 by partial derivating value of R equivalent with respect to R1 and partial derivating with respect to R equivalent with respect to R2. So partial derivative of R equivalent with respect to R1 will get the value here. R1 will becomes 1, R2 by R1 plus R2 minus of R1 R2 by R1 plus R2 square. After partial derivating will get the value of this. So we know the value of R2 R1. Substitute the values of R1 R2 in this, will get the value of I1 as 0.111. Same for I2, partial derivative of R equivalent with respect to R2. So here R2 becomes 1, so R1 by R1 plus R2 minus R1 R2 by R1 plus R2 square. After we know the values of R1 and R2, substitute the values of R1 R2 in this formula, we can find the value of I2 as 0.444. So we know the value of I1, I2, tolerance 1 and tolerance 2. So then we can find the uncertainty, that is sigma s is equal to plus or minus of I1 sigma 1 square plus I2 sigma 1 square. So we know the value of sigma 1 and sigma 2, I1 and I2. Substitute all the values in this formula, we'll get the values of uncertainty for the parallel combination, which is nothing but I1 is 0.111 into 25 square plus 0.444 into 10 square. After solving this value, we'll get the uncertainty as 5.23 ohms, which is nothing. In the given question, they asked for equivalent resistance with uncertainty. Equivalent resistance is nothing but 333 ohm plus or minus uncertainty is 5.23 ohm, which is option A. Option A. In this session, we have studied about how to calculate the R equivalent for the parallel circuit combination and the equivalent resistance with uncertainty. Thank you.